Thank you for the invitation to share my research and the thoughts on the impact of electricity shortages to the South African economy. Let's hope that we won't unexpectedly be interrupted by any power cuts during my presentation, although that would prove the points that I'm going to make about economic productivity and economic output and production, etc. So thanks for the introductions. Let me quickly introduce myself. Indeed, from the Department of Economics at University of Pretoria. Very happy to see in the program many of my colleagues from the university. Currently president of the South African Association for Energy Economics and also vice president for membership and affiliate relations of the international body, the International Association for Energy Economics. So my presentation today gives another perspective to the previous presentation, so builds upon that. We heard quite a lot on the why load shedding exists, the technicalities behind the choice of load shedding. I'm going to take us a step further, a step to the why we need to fix this situation. And not why we use load shedding to the problems we have, but what load shedding and the shortages cause to our economy, what problems it causes to attracting foreign direct investment, etc. So let me start by giving a little bit of background and perspective to that. So the South African energy crisis, we all know it's an ongoing period when our country experiences widespread rolling blackouts, not national blackouts, but rolling blackouts. Supply falls behind demand, threatening to destabilize the national grid. We all know it began in the later months of 2007 and continues to this day. Eskom, the government-owned national power utility and primary power generator, attributes these rolling blackouts to insufficient generation capacity, or as we heard, the technicalities behind that. And these rolling blackouts or load shedding are defined as the action to reduce the load, especially the interruption of an electricity supply to avoid excessive load on the generation plants. With the reserve margin estimated at 8% or below, such load shedding is implemented whenever generating units are taken offline for maintenance, repairs, or refueling, as we heard before. So it's a nice follow-up from the previous presentation, what I'm describing now. Even though the load shedding is not the actual crisis, but the response to it, the way to mitigate the crisis, understandably, the persistent load shedding is causing much frustration among South Africa's citizens, businesses and industry. So even though the concept of load shedding is actually the solution, the way of solving the crisis, the moment each and every one of us hears the word load shedding, negative feelings, thoughts come to mind. And let me not say what words come to mind. Frequent or long-lasting power outages are thought to constrain the economic well-being of households and businesses by reducing the output from existing electrical appliances and discouraging investment in new welfare-improving and income-generating ones. For businesses, unreliable electricity results in increased running costs and reduced productivity and profitability. The power outages in South Africa have caused many businesses in all sectors, from retail and service to manufacturing and industry, to lose sales. We're talking about estimations of the loss to South Africa's businesses and industries that battle with the scheduled nowadays power cuts. In the beginning, it wasn't scheduled at all, about 1 billion rands per state at times. For some firms, spending money on backup generators nowadays, which is an expensive alternative to grid electricity, becomes a necessity, reducing the amount they can spend on more profitable investments to that. And in terms of macroeconomics, the costs may be significant, and the economic losses due to power interruptions are estimated in several studies to cost between 1 and 5% of the current GDP. And in current times, with economic growth being so constrained, these numbers are really important for our economy. So although load shedding is perceived nowadays as the problem, everybody sighs at the hearing of the word. So what is the actual problem? The problem is that supply cannot or does not cover demand. And why is that? The demand rose substantially since the 1990s for a number of reasons, such as high population growth rates or high electrification rates. So we have more high population numbers or households connected to the grid than in the 80s or the 70s. We have the free basic electricity program. So more households connected to the grid, or more demand in that case. We have higher industrialization rates, higher urbanization in the country. At the same time, the supply side encounters constraints with slow maintenance, slow expansion programs, and a generation fleet that has reached their maximum life cycles, as well as rigid monopolistic market structures with regulated prices that aim through the years at not burdening the low-income consumers and generally the poverty-stricken society, but at the same time, not necessarily aiming at clearing the market conditions, in a sense that that regulation promoted prices that were not covering the costs of generation of electricity. So today I'm going to give you some of the findings from some research I've been doing with my co-authors recently on the electricity supply, or in a sense, the lack of electricity supply, or the unreliability of electricity supply, and therefore its impact from a macroeconomic perspective. So first, I'm going to say some analysis we did on our paper that is currently under review on the impact of the mismatch of this electricity supply and demand to economic growth for South Africa. And then I will follow that with another consideration in a paper that we published this year on the impact of electricity supply. And in that paper, we also introduced the impact of electricity prices on the attraction of foreign direct investment to the country, which is also quite important. So in the first paper I'm going to talk about, and I'm not going to present the papers in a more academic format with all the details, but you're more than welcome to contact me and I will share the papers for your review. So in that first paper, we try to determine the nature of the long-run relationship between, on the one side, the mismatch of electricity supply and demand, and on the other side, the South African economic growth in the period between 1985 and 2019. The motivation behind it is that in comparison to the vast research done on the effect of energy consumption on economic growth or energy supply on economic growth, there exists limited literature discussing the effect on the economic growth of the mismatch, either supply or shortage, surplus or shortage between energy consumption and supply internationally, and even less in South Africa. Even more, the policy discussion in South Africa in the last decade attributes the load shedding, the power cuts, all of these problems, and the negative consequences to the economy on this mismatch of the two, on the fact that supply doesn't cover demand. But still, we don't have enough research to see how this mismatch affects economic growth. The fundamentals of macroeconomic theory show that when there is a mismatch between the supply and demand of a good, whether it's a shortage or a surplus, resource allocation in that market is suboptimal. This suboptimality most overly presents itself in the South Africa's case as the electricity shortage. The consequences of this shortage, should they be significant enough, can potentially affect other sectors in the economy as well. If this is the case, the electricity shortage ultimately could become a barrier to income generation in the economy, and then hamper economic growth and development. And we've been experiencing that in recent years. South African businesses have suffered large losses because of electricity unsustainability. Industrial growth and therefore economic growth has been severely dampened by load shedding effects. And this is partially also because of the logistical issues caused by load shedding, like damage to equipment, for example, that has to be replaced. But also inadequate investment made by businesses into equipment that could mitigate the negative effects of load shedding. To address these adverse effects of load shedding, households need to invest in electrical infrastructure, which means they need to use their budget in something that they didn't think they should. By some, a surplus might sound like an ideal situation, have electricity supply more than we want to use. But in an economy with challenging conditions, financial resources and government budget does not allow for overinvestment towards an energy infrastructure, and such a situation would mean certainly a loss of resources from other sectors. So we need to be, policymakers need to be sure that what they invest in the energy sector will be used in a demand. The theoretical framework that we use starts from an endogenous growth theory model, starting from a general economic growth idea that is determined by factors like technological progress, where you see here as capital A, and a function of capital accumulation, capital K, and employed persons, capital L, or labor. And then mismatch electricity supply and demand of the economy that we calculated by subtracting national electricity consumption from national electricity supply is incorporated in the model through A, which is the technological progress. It has been shown in the literature that energy, and hence electricity, has a relationship with technology. And one obvious channel through which this relationship could present itself is through the fact that one is unable to innovate and use technological advancements without energy, and particularly electricity. To reach the optimal level of technology transfer and in turn the optimal rate of growth in technological progress, energy must be used efficiently. And therefore we use this proxy of energy, the mismatch between energy and supply, or the difference between energy supply and demand in the production function. So to continue a little bit with this idea of the model that we used, and without presenting all the details of the model, I'm presenting here the table, but what I want you to take from this model is that in the one side, we use as a dependent variable economic growth, and we saw that this mismatch between electricity supply and demand is a significant factor to economic growth. But on the other side, what we also show is that economic growth is also a significant factor to this mismatch of electricity supply. So these two factors, mismatch of electricity supply and demand, and economic growth, affect each other. So the main findings of our study indicate this relationship between these two. And in a sense, an important finding of our study is that increasing economic growth is a significant contributor to the rise in South Africa's electricity surplus. And also that the rising surplus of electricity enhances economic growth for the South African case. These findings are a little bit at odds with this paper's initial hypothesis that any inefficiency, shortage, or surplus in the electricity market ought to be adverse for economic growth. And what we mean with that? This outcome that the rising surplus in the electricity market serves to bolster economic growth in the long run is easily reconcilable. It's rather intuitive if you think about it. When the economy grows, this facilitates the rise in electricity supply relative to electricity consumption. This mismatch is conducive for growth only when the supply of electricity exceeds the electricity demand. Load shedding occurs when there's not enough electricity to meet the amount of electricity demand in the market. And thus load shedding and other electricity shortages serve to undermine the potential for the electricity market to positively affect the South African economy in the long run. Eskom's aging coal power plants pose another threat to electricity supply security in the country. And Eskom is reported to be managing a power plant system with an average age of 37 years. The implication of this is that Eskom often encounters unplanned maintenance costs, which in turn delay plant maintenance projects, and then the system is unreliable. The problem with that is it creates bigger mismatches between the supply and the demand, and therefore that might affect the relationship between the mismatch and the economic growth. To take the discussion one step further, I'm going to take you to connect this availability and reliability of electricity supply with foreign direct investment. So the foreign direct investment host countries get benefited by inward foreign direct investment flows, but the inflow of the new expertise, technologies, and human and physical capital, as well as organization methods and production patterns. So all elements that have the potential, all these elements have the potential to improve economic productivity, to improve economic growth and development. So it is something that host countries of this investment benefit from. The decision in favor of FDI and the geographical preference of such an investment is highly dependent on the conditions of the host country. So for a country to decide to invest in South Africa, for example, they evaluate a number of factors in South Africa's conditions. So these factors include traditionally, for example, the price and quality of natural resources, physical infrastructure, macroeconomic conditions of the host country, political stability, and investment certainty. FDI is chosen to be directed to a country that enables a market that reduces costs and risk and promotes competitive advantages. Among all of this, energy had become in recent years a strong factor of production, and the availability of energy whenever needed in the production process is a crucial determinant of the viability of business and capabilities for profit maximization. That's why investors choose the country to maximize the profits. So the energy factor, its availability and reliability is really in the heart of a debate of whether investors will come to our country or not. So for this paper that I'm presenting to you, that was published this year, we looked at these factors: electricity supply and prices, as factors for attracting investors to South Africa in the period 1985-2018. And what we found is electricity supply is actually a positive contributor to inward FDI, and electricity prices are a negative contributor to inward FDI. So the higher the prices, the lower the chances of attracting investment to the country, and the higher the electricity supply, the potential to attracting investors get higher. These results were confirmed for different specifications of models we looked at, combining with the economic growth of the country, political conditions of the country, we looked at different dummies in the country, in different structural breaks in the country in this period, because we all understand that this period was not homogeneous. The conditions, the political conditions in the country were not the same. So it goes without saying that from this analysis that energy policy makers will have to look for solutions on how to stabilize the conditions of electricity supply if we want to attract investors to the country, because interruptions have been affecting the local economy, making the producers losing revenue through that. Just to give a little bit more on that, policymakers, the suggestions from our model could potentially consider electricity subsidization programs to attract investors in the country. An example of such an approach is offered by India and how the country dealt with internet availability, for example, in the beginning of the at the end of the 2000s. And another suggestion we give in the paper could also be that policymakers could promote other technological avenues for accessing energy to investors, alternative to the purchasing electricity from the national grid. If investors before decision-making evaluate the conditions in the country and conclude that installation and maintenance of self-generation of electricity are substantially more cost-effective in South Africa than other countries, that will be considered an asset for the country. So it's all about how do we make business, to set up a business easier for investors to attract them to the country. Some concluding thoughts from my side. It's one of these things that doesn't usually happen. Policymakers, industry, academia, households, businesses, society, everybody agrees on that South Africa needs to look at solutions on this problem. It's an existing problem, but we need to look at solutions, and we might need to start looking at new solutions. The electricity or broader energy sector problem is not a sectoral problem. It doesn't concern a specific economic sector in the country. It concerns the whole economy, the whole society. It affects everybody. And from what I discussed today, the reliability of electricity supply affects the attraction of foreign investment. The electricity supply, but services demand, affects the promotion of economic growth. And in current times, economic growth is constrained. The pandemic did not allow us to grow as it was estimated, as it was forecasted, and certainly load shedding, power cuts doesn't allow us to go forward either. The 2021 load shedding waves, possibly the future waves, do not have the same magnitude and impact to the first ones we had in 2007. Some people argue that why they're the same hours. I have many reasons behind that. The 2007 ones, first of all, they were unexpected. We didn't know when they're going to come. They were not organized, neither by region, nor by sector, by time. We had no idea when we're going to have electricity and when we're not going to have electricity, contrary to now that things can be more organized first. Second, by now, the technology allows sectors to be more energy efficient. We have changed the behaviors of the consumers. Many sectors are more prepared. They have adapted to the new conditions. We are looking at technologies that allow many sectors to self-generation. We heard at the introduction of the session today about the new era that we are entering, about self-generation. The renewable energy technology costs are not the same as they used to be. So definitely the options in our availability are not the same as they were in 2007, neither for businesses or households, neither from accessibility point of view, nor from affordability point of view. Then from an economic growth point of view, we are in a situation where we don't know if lower economic growth is a good or a bad thing for our demand. We are experiencing lower economic growth and, in a sense, lower demand. If the economy were growing in much higher levels, the demand for electricity would have been extremely higher, and hence the supply would have been even more constrained than now. And again, I'm putting that in inverted commas. I'm not sure if that's a good or a bad thing. Also, the price restructuring since 2008 has made consumers changing their behavior. I'm going to refer to electricity price elasticities and how that has changed since then. So definitely the impact of the load shedding is not the same. So I'm arguing that the solutions to load shedding from a demand side point of view cannot be the same. We should not look at the same arguments we had in 2007. But also the system should learn from actions that were taken or not taken in the past. So opportunities that were not taken to fix it until now. And I'm not talking necessarily technical parameters, but institutional parameters, policy parameters, management parameters, involvement and the role and the stakes at place of a variety of players in the decision-making that might have been the reason for the lack of drastic solutions or the speed of taking action that make economic sense and have a sustainable nature that we're not taking until now. And with that, I'm gonna leave now, and I'm happy to be part of the discussion. Thank you very much.